Hello class. Today we're going to be covering 8.1 and 8.2. Now, I know that it seems like two lessons, but 8.1 is really just asking you about what does this ax squared do, and then in 8.2 they just add on the plus c. So it's really not a lot of new information, and a lot of this you already know from when we did absolute value transformations in Algebra A, okay? So today's lesson is about what happens or how do quadratic functions change with their graph. So a quadratic function is anything in a degree of 2. Now typically this is what we call standard form, where we do ax squared plus bx plus c. So this is a typical quadratic. Now sometimes that means that you would have even a number out front, so you could have like 2x squared plus 7x plus 10. That's a quadratic. You might also only have two terms, so you might have 5x squared minus 6. That's also a quadratic. Or you could have x squared minus 3x. That's also a quadratic. But if you were to drop the square term, and let's just say you did 3x plus 7, that is linear. That is linear because notice it's kind of like slope, mx plus b. So the whole idea behind this entire chapter, really, chapter 8 and chapter 9, is what are we doing with these square terms, okay? So a few other vocabulary terms here. This is what they always refer to as the parent. So let me just kind of show you a quick sketch. If this is my x and y axis, a parent, or this just x squared, is a nice parabola. So it's kind of this U shape. So if we were just to draw this kind of a U shape in, that's what it would look like, okay? So this is our parent. So sometimes they call that f of x is equal to x squared. Now remember, this is function notation, so don't let it throw you off. It's not a big deal. It's really the same thing as saying y equals, okay? So that's just function notation. So we call this a parabola based on its shape. Vertex is this point right here. So this is your vertex. Now be careful when you might think of the vertex as the lowest point. I could also draw you a parabola where the vertex might be the highest point. So we really like to think of the vertex as the turning point, okay? And that is another thing we're going to be talking about, is which way do these open, and then how do we describe this vertex. So that's some other vocabulary that will be coming up later. And now axis of symmetry. Axis of symmetry is the line of reflection, and I really probably should put on here that splits the graph in half. So in both of these two particular examples, the y-axis is your line of symmetry, because do you see how it splits it right down the middle? And many times we label this AOS. So this would be our axis of symmetry. Do you see the vertex? So our axis of symmetry would go right down the middle like that. Let me grab you a separate sheet here and draw you one. Now your parabolas today are all going to be symmetrical on this y-axis. But in lesson 8.3 and the rest of chapter 8, they will not. They might be way over here. So the axis of symmetry would be the line that would split this in half. So axis of symmetry. Now remember what I'm saying here. Be careful. It's a line. Do you notice that this is vertical? So you're always going to give me your answer as x equals and then whatever number this is. And so we're going to talk about that, okay? So just remember, axis of symmetry is a vertical line in our class. Now there are some parabolas that do go kind of on a diagonal. There are some that might even go sideways, stuff like this. We will not have any of those in our class. Ours will either go straight up or they'll go straight down. So all of our axis of symmetry is going to be x equals and then whatever this number is, okay? So we'll go through some examples so you can see how that works. And you notice how a lot of times we abbreviate that because we don't want to always have to write out axis of symmetry every time. So on this first example, they're giving you the picture already drawn. And so they just want you to go through and they want you to identify these 4 pieces. So notice there's our vertex. So if we look at this parabola, the vertex is the turning point. So this point right here, if I can, let me just highlight it there so you can see it. We just have to give the ordered pairs for this coordinate. So it looks like it's at -1 and up 1. So then my vertex would be -1, +1. That's where that point is sitting at. Now the axis of symmetry, remember, is the line that splits this graph in half. So do you notice, again, we said it's x equals, but do you notice it's always going through the x part of the vertex? So once you have the vertex, you also have the axis of symmetry. So again, let me just grab a blank sheet of paper here. Let's say your vertex was 3, -10. Well, that means your axis of symmetry would be x equals 3. The axis of symmetry is always from this number because it's the x coordinate. So again, if your vertex was over 3 down -10, now we don't know which way this opens, if it opens up or if it opens down, that's not going to affect the axis of symmetry. So the axis of symmetry is always off just the x coordinate, okay? Now, everybody's favorite, domain and range. You're going to see this resurface in this chapter, okay? So parabolas, what you have to think about with parabolas is these are going to continue to open. Do you see how they have arrows on the end? So this parabola is just going to keep opening wider and wider and wider and wider. So it would be all real numbers because every single x value is going to get covered. Now look at your range. Your range is what are your possible y values. So notice the lowest y value is at 1, but then what's the top? Do you see how it continues just to keep going and going and going? So we want to use an inequality. So we would want to say that y is greater than or equal to 1. Now, again, one thing might pop into your head. Will it always be this? In our class, yes. In our class, the domain will always be all real numbers because, again, if we were to look at all of our parabolas, if they're opening up, if they're opening down. Now, notice this kind of almost looks like it goes straight up, but it doesn't. Parabolas actually kind of go out more, and we're going to talk about that here in the very, very next step is our a value. What is our number in front of the x squared? This will determine essentially how narrow your parabola is or how wide the parabola is. Now remember, we did the exact same thing when we did absolute value. Absolute value is a V shape. But if you put a number out front, like if you put a 7, whoa, that's a super steep V shape. If you make this a fraction, like 1/2, now you're looking at a wider V. We're going to do the exact same thing here, vertical stretch and vertical shrink, with parabolas, okay? So yes, your domain should always be pretty easy. And if you notice, your range is coming from the y part of the vertex. And then the symbol is really which way does this open? Does it open up? Because if it does, it's greater than. If it were to open down, then it would be the less than. And yes, we always put a bar underneath. We will always have closed circles right there. And to have an open circle, you'd be getting into some really, really tricky problems. So you're not going to see that in ours. So I don't want to say that this is a freebie, but you should always get this one right. And then as long as you get your vertex, these other two kind of come from the vertex, okay? So let's just do a quick review here. Notice the a out front when a is greater than 1. So let me give you an example, like y equals 7x squared. That 7 is going to make it quite a bit steeper. So we call that a vertical stretch. If we were to change this a value to be between 0 and 1, so potentially a fraction, so let's say 1/2 x squared, that's going to make it wider. And so we call that a vertical shrink. And I can write that in here too. This will be more narrow. and this will be wider. And if you have a graphing calculator at home, you could type this in and play around with it. So let me just try to show you real quickly. If I go to my y equals and I type in x squared, so that's going to be what we call the parent. Let me just change my contrast. I think that helps a little. All right, now the second one I'll do 7x squared. And then the third one I'll do 0.5x squared. And then we'll see how these graph. So the parent is going to come first. That's the parent. Now here comes the 7. Oh, yeah, you can see it there. That's kind of real skinny, the red one. And now here comes the 1/2. Now, do you notice the 1/2 is not too much wider, but it is wider? Why don't I show you, let's show you a really drastic one. How about let's go like 0.1x squared. Let's see if it'll graph that. So our parent will go first, just the regular x squared. That's a parabola shape. And then here's our 0.1. So the closer we get to 0, do you see how the wider it is? What if we change this to a 0.01? I'm wondering how wide that's going to be. So if you have a graphing calculator, or if you don't have one, there's a lot of online tools you can use as well. But you can type these in. Oh, look at that. It's like almost practically flat. See it going along and then it comes up. There's not much space between the axis and the curve. So the closer you get to 0, the flatter it becomes. The further you get away, the steeper it becomes, or more narrow, okay? Now negative. Negative is going to do the same thing that we saw with absolute value. It's just going to be a reflection. So notice I didn't do the parent, I just put the negative. But do you see how it's just flipping it down? Okay, so let's say negative x squared. This will be a reflection over the x-axis. Or we could say it's going down. Now this really is your lesson for 8-1. That's it. In an 8-2, all they do is add the c on, which is like a constant. So it would look something like this, x squared plus 5. And again, we had this with absolute value. So we do x squared, say, plus 5. Notice what it's going to do to that vertex. Do you see how it just took my vertex and it just moved it up? Okay, so we call this a vertical translation up, and then we say the number. And we're going to have the same exact thing with a subtraction. So we would have y equals x squared, say, minus 3. And so we would just say vertical translation down, because it's just going to move it down by the number. Now, yes, you can put these two together. That's what they're going to end up doing. They're going to end up throwing a number out front and an addition or subtraction sign, okay? So on the next page here, I just have 4 examples of some different quadratics. Notice this only has the 1 term, so we're looking at a monomial. Notice this one has 2 terms, so now we've got a binomial. That's all we're going to get to today is the binomials. If you're thinking, what about 3 terms? That's lesson 8-3. So we'll get to that tomorrow, okay? All right, so remember, we are comparing it to the parent. They call this the parent. So we're asking ourselves from here to here, what changed? And the only thing that changed was they added that 5 out front. And so based on our chart from the other page, if we add a number out front that's greater than 1, we call that a vertical stretch. So I would say vertical stretch of 5. We always want to give them the number as well, because that way we know how much it really affected it. Because a vertical stretch of 2 wouldn't be that much. But the closer or the further away we get, like if we got to 10 or 12, it'd be really narrow. Now, I know you don't have a graph here, but just envision, it does say graph, which we know you guys don't have graph paper, and that's going to be really hard for you to demonstrate on the computer. So just kind of, practice or think of these graphs in your head. Remember, the original is like this. This is the parent. Now, all you're doing is you're taking these sides and you're stretching them. You're stretching them up. So this is all the 5 would look like. That's what the 5 is going to do. So it's not changing my vertex at all. So my vertex is still right on the origin, 0, 0. My axis of symmetry, remember, splits it in half, and it's this first number. So my axis of symmetry, you have to do x equals, okay? Domain, we talked about this. It's kind of a freebie. It's going to be all real numbers. And then look at your range. Your lowest point is 0, and then it's getting bigger. So we would call this greater than or equal to 0, okay? So how about I'll try one more, because this is really from lesson 8.1, and this is from lesson 8.2. Oh, one other thing sometimes is they'll ask you about opening, okay? So we can see from our graph that this opens up, which I want you to kind of think of this as like a smiley face, like it's happy, okay? So this is opening up, which is a good thing. All right, number 3. Notice we're still comparing it to the parent. And the only thing that changed on this time is they put this -2. Notice there's nothing out front. So if you imagine, here's our parent. So this is our parent. This -2 just took this graph and went boom, boom. It just moved it down. So it's the exact same opening, but notice how it just moved it down. So we would say for our comparison, we would say vertical translation down 2. And then what is this vertex? What is this point right here? Well, notice I'm on the axis, so it'd be 0, -2. And so that would be my vertex. My axis of symmetry is splitting it in half. Now again, don't think it's always going to be a 0. In today's lesson it will, because today's lesson they're on the axis. But in other lessons, this parabola is going to get shifted off. So just make sure you pay attention to where is that point. Now the domain is always going to be the same for the entire chapter. So I guess again, that one's a freebie. And now look at your range. Now be careful with your eyes. This is the y coordinate. So this is at -2 and it's getting bigger. So we want to say y is greater than or equal to -2. Remember, which way does this open? Do you see how it's opening up? So it's happy. That means it's going to be the greater than symbol, okay? So if you want to pause the video here and try these other two just to give you some practice, this is a -1/3 x squared plus 1 and a -4x squared minus 8. All right, hopefully you paused it and tried it on your own. Now this one for our comparison actually has 3. Do you notice it's got a negative, it has a 1/3, and it has a +1. So our comparison is actually 3 answers. So the negative is going to be a reflection over the x-axis. And again, I'm getting that from the chart. When it's negative, it's a reflection. Okay, the 1/3 is a shrink. Do you see how this was bigger than 1? This is smaller than 1. So this is going to be a vertical shrink of 1/3. Kind of running out of room here. And this is going to move it up. So this is going to be vertically translation up 1. So if I were just to give you a rough sketch, here was my original. This negative is going to reflect it. So the negative is going to make it go like that. That's the negative. The 1/3 is going to make it wider. So it's going to go wide. And then the +1, so this one's gone now. Okay. Then the +1 is going to take this dot and just yank it up 1 spot. So it's this exact graph, just up 1. So this would be our final. Okay, that's what it looks like. So now let's grab our vertex. Our vertex is right here. So it's at 0, +1, because we moved up 1. Our axis of symmetry splits it in half, so that's x equals 0. You can get the domain real quick. and then look at your range. Ask yourself, which way does this one open? Do you see how it opens down? So see how it's kind of going down? It's like a frowning face. Okay, so it's going down. So then this is going down, so we want it to be less than. So we want it to be less than or equal to 1. Okay? And again, notice x coordinate, y coordinate. So you really have to make sure that you are getting that vertex correct. And if you want me to show you in the calculator here, when you go into your y equals, remember that when you put fractions in, you just have to put them in parentheses. So if we put them in, type this in as 1/3, because that is a repeating decimal, it's not going to make a difference if you do 0.3, but if you don't want to get any error, and then we do x squared plus 1, and then let's hit graph. Now notice that doesn't look necessarily probably as wide as the one I have drawn. Let me type in the original for you. How about I'll keep it as a negative x squared plus 1. So I'll just take out that 1/3 so you can kind of see the difference there. So it's going to be the same vertex, but do you see how much wider it is? Okay. Our graphs are just a visualization where nobody's going to put a protractor down on these. So if it's wider, just make it wide. If it's narrow, make it narrow. Don't worry about, oh, that's too wide, that's too narrow. That's okay. We're just trying to give ourselves a visual picture, okay? All right, let's quick run through 5. Notice 5 also has 3 parts. It's got a negative, it's got a 4, and it's got an 8. So our first comparison, again, is going to be the reflection over the x-axis. You do want to try to make sure that you're saying x-axis because there is a y-axis reflection, but you don't get into that till Algebra 2, so we don't have to worry about that for now, but that will exist. The 4 is greater than 1, so that's going to be a vertical stretch of 4, and again, it's important that you give the number. And this is a -8, so it's going to shift it down. So it's going to be a vertical translation down 8. And again, yes, we will have horizontal translations, just not until later in the chapter. Okay, actually 8.3 has some. So if you look at your parent, this is the parent. You're flipping it down because of the negative. So there it goes. There's the reflection. The stretch makes it skinnier. So now this one's gone. Okay, so there's that one. And now we're going to take this and shift this point down 8. So it's going to go straight down. So it's going to have the same shape. It's still having the down skinny look, but it has to go down to a -8 spot. Okay, so then look at this point, and this is your vertex. So we have 0, -8. And once we have that vertex, we can get our axis of symmetry. It's always a line that splits the graph in half. So we do x equals 0. We've got our freebie. Now you might think that this doesn't look like it continues to open, but if you type it into your graphing calculator and you use the table feature, -4x squared minus 8. Now you can see the graph if you want. It's going to be kind of down towards the bottom because this is a 10 by 10, so it's going to be a little bit narrow. You can barely see it just right down there in the bottom. But watch if I go to the table. My x values, they are increasing, but holy moly, look at when x is 10, look at your y. Do you see how x is still going? But it's kind of slow compared to the y's. I mean, look at when x is 20, look at your y coordinate. You're in 1,608. Man, comparably, the y's are going out significantly faster, but the x's, they're still going, okay? And I could go the other way too and show you the negatives. So it is all real numbers. And notice we were at -8 and we're going down quite quickly. But we don't have to tell them that. We just have to say less than or equal to -8. We don't have to tell them how fast we're going down. We just need to say that. And again, this does open down. Okay? So that was actually 2 lessons. 8.1 was just the x squared part. Just what does this front number do? And then in 8.2, they just added on the constant. Now, in 8.3, they're going to put the middle term in. So they're going to do ax squared plus bx plus c. They're going to throw that middle term and you're going to have a trinomial. All right, I hope that helps, and please ask if you have any questions.